Good day, everyone. Today we shall be diving into another aspect of electricity. We'll be unveiling the fundamentals of electricity. In this aspect, we'll be looking at the concept of voltage, resistance, inductance, and capacitance. These are the building blocks of electronic circuit. All right? I'm sure you'll be interested in knowing this. So let's dive into this. What then is voltage? All right? When we talk about voltage in electricity, it's a driving force. Without voltage, you can't talk about electricity, you can't talk about the flow of current. So we say voltage, sometimes known as potential difference, simply means the work done in moving a unit electric charge between 2 points in an electric field. So the work that needs to be done so that a charge can be moved from one point to the other is what we call voltage or potential difference. And the instrument that you use to measure voltage or potential difference is known as voltmeter. This is a typical example of a voltmeter. You can see that it has a pointer and a calibration. So this pointer here, as it moves, as it divides toward the right hand side, it shows that the work done is increasing. Okay, so it's simply the work done to move a charge from one point to another in an electric field. That's what the voltage is, and we call it potential difference, or in a short form, PD. PD. Right? Now, let's talk about another concept again in electricity. That's resistance. Resistance simply means opposition to the flow of electricity. And we usually use capital letter R to symbolize resistance. The device that exhibits this resistance is what we call resistor. Okay? Now, resistance is actually measured in ohms. The unit of resistance is ohms, and the instrument you use to determine resistance is called ohm meter. The device that exhibits resistance is known as resistor. The ability of this resistor to oppose resistance, to oppose current, is called resistance. So it's very important. In the market world, they look like this. This is it here. This is a color code kind of resistor. Okay, their function in an electronic circuit is what? To oppose the flow of current. Okay, another concept again we want to know is known as the inductors. The inductors, what they do is to store energy in magnetic field. If you go to the market, this is how they look like. They're just coils, okay? Coils that has a magnetic core inside. This wire you see here is wrapped around a magnetic core. Okay, and what does it do? This device usually, like I said, consists of coil, opposes changing current. And when it opposes changing current, what happens is that it induces voltage into the circuit. So it's a device that stores voltage, which is known as the energy, okay, in magnetic field. It opposes current and then induces voltage that is stored in magnetic field. It stores its own energy in form of magnetic field. All right, this is the magnetic field here, and this is the inductor here. So whenever it has opposed current, it does that and then store the voltage as a magnetic field. Okay, now let's talk about inductance and induced current. The ability of this inductor to generate this voltage you talk about is what we call the inductance. The ability of the inductor to generate the voltage or the potential difference, which we call electromotive force in this case, is known as what? The inductance. And inductance is measured in Henry. The unit of inductance is Henry. Okay? The unit of inductance is Henry. And then it's either it induces voltage or it induces current. This current is induced when there is what? A relative motion between the conductor and the magnetic field. When I say the conductor now, it's the coil. So this is the inductor here, which is the conductor, and this is the magnetic field. So whenever there is a relative movement, when you move the magnet or you move this coil, you see that a current is induced. And how do you know that? Because when current induced, this ammeter will deflect, showing that there is an induced current. All right. So that's how it works. That's how it works. Um, when there's a relative movement between the magnet and the coil, current is induced into the circuit, and that's what we call the induced current. Okay, having said that, we now look at another device in electric field that's known as capacitors. The capacitor also store charges. Okay, the capacitor store charges while the inductor store its own charge in form of a magnetic field. But this capacitor store its own charge in an electrical field. So a capacitor therefore is a device specifically designed for storing electrical charges. Now, capacitance, we can say, is the ability of the capacitor to store charge, but in mathematical terms, we say capacitance is the ratio of electric charge to the potential difference across its plates. Okay, capacitance is measured in farad. This is a symbol of a capacitor. It has two parallel plates. This capacitor 1, C1. So it has two parallel plates, positive and negative plates. This is another capacitor, positive and negative plates, capacitor C2. And this is another capacitor, positive and negative plates. Sometimes we call this plate electrode. Okay, so capacitors can be charged. When they are charged, they store their charge just like battery store charges. Okay, but they do not store charges for a long time like battery does. Right? Now, how does the capacitor work? Like I said earlier, if you want your capacitor to store charge, you need to get the battery and charge it. So you have to charge the two plates or the electrode. Having charged the electrode, the capacitor will retain the charges that have been transferred from the battery. So here now, this is a charge one now. That's step 2. And then step 3, you can now include or add your capacitor in your electric circuit. Now, in between the two plates, there's what we call the dielectric. The dielectric is an insulator like air that acts like that act like a non-conductor in between the two plates. Okay, and this is where the capacitor is able to store a charge. By the time you have this dielectric in between them, the charges are not discharged because there is no contact between the two plates. We give the two plates the ability to store their charges without being discharged. All right. Now, capacitor comes in different ways based on the dielectric, based on what is between them. This dielectric, whatever is between the two plates, gives us the type of capacitor. For example, when we say we have air capacitor, it means that the dielectric between the two plates is air. Okay. When we say paper capacitor, it means that the dielectric, that is the insulator between the two plates, is paper. And when we talk about the micro capacitor, we say that the dielectric between the two plates or electrode is a solid dielectric material. And we have other types of capacitors too, based on the function. We have the variable capacitor and the fixed capacitors. The variable one are the one that you can change the capacitance by controlling their buttons. If you want maybe 10 microfarad capacitor, you move just like you increase your fan to 1 to 2 to 3. That's variable. But for fixed capacitor, if it is 10 microfarad capacitor, that is it. You can't change it. But the variable one can change from one form to the other by just switching it from a bigger capacitance to a smaller capacitance. Right? So these are the different types of capacitor we have based on the dielectric between them and also based on their design, whether it is fixed or it is variable. We also have the electrolytic capacitor, okay, based on the fact that the two plates are actually, one is positive and the other one is negative. Okay, so we have different types of them based on their function and their their electric and the design as well. Okay, let's talk about another important device in electricity, like transformer. Transformer is a very common device that almost everybody knows about. Transformer, from the name, what it does is to transfer energy. It transfer energy. So a transformer is a device that transfer electrical energy between circuits via electromagnetic induction. This is a typical skeletal diagram of a transformer. It can come in, it has two types. We have the step-up transformer and the step-down transformer. Now, before we talk about the type, let's talk about the composition of a transformer. A transformer consists of primary coil, secondary coil, and also the magnetic flux. Okay, the primary coil is the part that is connected to the source of the electrical energy. Okay, that's where the source of electrical energy comes from. We see here in it we have what we call the primary current. The IP is the primary current. The EP is called the primary voltage, and the MP is called the primary number of turns. At the other end is the secondary coil, which has IS, the secondary current, NS, the secondary number of turns, and ES, the secondary voltage. Now, what do we mean? We already know what current is, the charge that flows. Then this N represent the coil, this thing you see here, the coil that we showed you earlier for inductor. Okay, the number of coil like a rope around the primary circuit here. Okay, so we have it both at the primary side and the secondary side. So this N number of coil. If we count this now, we could see for the secondary coil, we could see 1, 2, 3, 4, 5. So it has 5 turns. And why for primary coil? In this particular transformer, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 turns here, number of turns. Now, this helps us to determine the type of transformer it is. Now, if the number of turns in the primary circuit is bigger than the number of turns in the secondary circuit, then we will say that this transformer is called step-down transformer. But whenever the number of turns in the primary coil is smaller than the number of turns in the secondary coil, then you call that transformer step-up transformer. All right, very important that you know this. This is the two types of transformer we have: the step-up and the step-down transformer. Okay, so the same thing. Another way you can know step-up transformer is if the secondary voltage or primary voltage in this case now EP, if it is smaller than the secondary voltage, then it's still what? It's still step down transformer. Whenever the secondary part is smaller, whenever ES is smaller than EP or NS is smaller than MP, just see it as step down transformer. But when it's at the other at the reverse case, where NS is bigger than MP and ES is bigger than EP, just know that it is step up transformer. So we have a formula for this. That means this is the formula here. The primary voltage, which is EP, all over the secondary voltage, which is ES, equals the number of turns in the primary circuit over the number of turns in the secondary circuit. So with this formula, you can determine either the number of turns in the primary circuit or the number of turns in the secondary circuit, or the voltage in secondary circuit or the voltage in primary circuit. All right. So, for example, now we can decide to step down a voltage from 220 volts to 110 volts. If you want to achieve this, because you are stepping down, you make use of what? Step down transformer. Okay, so let us see an example of how we use transformer. Let's say a question here. The question says, the primary voltage of a transformer is 10 volts. That simply means that our EP is 10 volts. And the primary winding is 20 tons. For primary winding, meaning that the MP, number of tons, is 20 tons. So if the secondary winding is 100 tons, that means our NS is 100 tons. Find the secondary voltage. So you have to look for our ES. So making use of the formula we said earlier, the ratio of the primary voltage to secondary voltage equal to the ratio of the primary uh, number of tons to second number of tons. When you do that and we substitute our value, our EP is 10, we substitute it here 10. Our ES is what we don't know, that's ES equals our NP, which is 20, that's it here, and our NS, which is 100. So from here now, we can easily detect that our secondary voltage is 50 volts, okay? Using your knowledge of equivalent fraction, I easily know that our secondary voltage is 50 voltage. All right, in as much as we have two types of transformers, step up and step down transformer, each of these types can come in smaller form or in bigger form. So the smaller version of step down transformer, okay, are used for our household appliances. Even our laptop charger, they have their step down transformer in it, okay. So with smaller version of step down transformer, we use them in our household appliances, while the larger ones are used as substations, okay, like you could see here now. This is, we use step down, we use a bigger step down transformer for substation like this before it now get to our respective home. So these are stations, so these are tensions that takes the step down transformer current down to our household, okay. So the step down high voltage for residential purposes, all right, so that it does not, cause fire accident. All right, so we shall be doing our cutting here today. I hope you have learned something on the fundamentals of electricity. Thank you for watching and have a wonderful day. Bye for now.